Morning, guys. So today I posted a practice worksheet to get a little bit more practice with the emissions of photons. It's not something I'm grading or collecting, but I highly recommend that you work through it on your own. And then just to help you out, I've posted both the PowerPoint that I'm going to go through with you guys right now as I go through how to solve all these problems. So it's the same hydrogen atom that we've been working with. And the thing to note is we're working in joules, so that means we will be using Planck's constant in joule seconds. So let's look at our first question. Our first question asks, if an electron in the hydrogen atom falls from one energy level to n equals 2, the wavelength of the photon emitted in this process was 434.1 nanometers. What was the initial energy level of the electron? So as we do with any problem, you want to identify what you know. So we always know the speed of light. So c equals 3 times 10 to the 8th meters per second. We always know Planck's constant, so 4.14 times 10 to the negative 15th electron volt seconds, or 6.63 times 10 to the negative 34th joule seconds. And we already said that because the table's in joules, we're going to use Planck's constant in joule seconds. And this problem tells us that the wavelength of the emitted photon is 434.1 nanometers. Now, since the speed of light is in meters per second, we want to change the nanometers to meters. So we simply convert, because we know that 1 nanometer is 1 times 10 to the negative 9th meters. And that will give you 434.1 times 10 to the negative 9th meters. So what do you need to find the energy of the photon emitted? So essentially, which equation will you be using if you're looking to solve for energy? Because if we want to know what energy level the electron starts at, we need to find what total energy is emitted. And we will use the equation to solve for energy. So E equals h times the speed of light over wavelength. So now I simply need to solve. Using what I know, using my equation, I will solve for the amount of energy that is emitted when the electron moves from one energy level to the other. And I find that the energy is 4.58 times 10 to the negative 19th joules. And again, I use Planck's constant in joule seconds because the energy level diagram gives energy in joules. If you solve this, and please do, and you do not get this number, that means a couple things. Did you use parentheses? If not, that's probably why you got the wrong number. And also, are you doing it one step at a time? So I wouldn't put this all in my calculator at one time. I would first do the 3 times 10 to the 8th divided by the 434.1 times 10 to the negative 9th. I'd press enter, and then I would multiply by 6.63 times 10 to the negative 34th. So when in doubt, you want to slow down your process a little bit when you're putting it in your calculator. Now, this isn't the final answer because what this problem is looking for is what energy level, what state did the electron start at? So I can use this energy to find that information. So to determine the initial energy level, I need to determine how the electron can emit 4.58 times 10 to the negative 19 joules to get to the n equals 2 energy level. So what I did first is I changed this slightly. So I moved the decimal over to write the numbers 0.458 times 10 to the negative 18th joules. And I did that because if I look over at my diagram, the units are in 10 to the negative 18th joules. So it will make my life a tiny bit easier. Then I said, okay, I know that the electron is in the n equals 2 state. So if I find the difference between the n equals 3 and the n equals 2 state, is the energy emitted 0.458 times 10 to the negative 18th? That one doesn't work. But then if I find the difference between the n equals 4 and the n equals 2, so 0.545 minus 0.136, I do get that the difference is 0.458 times 10 to the negative 18th joules. So that tells me that the electron started in the n equals 4 state. Cool. So let's move on to the second question. Determine the wavelength of a photon emitted when the electron falls from n equals 2 to n equals 1 within the hydrogen atom. So just like we do always, identify what you know. That's always your first step. So we know the speed of light, we know Planck's constant, and I know that if the electron falls from n equals 2 to n equals 1, the electron will emit 1.634 times 10 to the negative 18th joules. So I found the difference between the energies of the n equals 1 and n equals 2 state. I simply subtracted what was listed there. So step 2, what do we need? So what equations do we need to solve for the wavelength of the emitted photon? Same equation we used before, E equals Planck's constant times the speed of light over the wavelength. So now I just simply need to solve. So I have my energy, 1.634 times 10 to the negative 18th equals Planck's constant times the speed of light over the wavelength. So I want to get wavelength by itself. So my first step, I divided both sides by Planck's constant. So I divided 1.634 times 10 to the negative 18th divided by 6.63 times 10 to the negative 34th. Again, make sure you're using parentheses. And I get 2.46 times 10 to the 15th equals 3 times 10 to the 8th over the wavelength. I want wavelength out of the denominator, so I multiply both sides by lambda. And then I can divide by 2.46 times 10 to the 15th on both sides to get wavelength by itself. So 1.22 times 10 to the negative 7th meters. All right, number 3. If an electron is in the ground state, how much energy would an electron need to ionize? So to ionize means that it gains enough energy that it can completely leave the atom. So if the electron is in the ground state, it would need a minimum of 2.179 times 10 to the negative 18th joules of energy to ionize, to leave the atom completely. And I found that simply by looking at the diagram. Okay, so for an electron in the n equals 4 state, how many different possible photon emissions are there in order for the electron to return to the ground state? So this is drawing all the possible paths that can be taken. So first I have the n equals 4 to n equals 1. Then I can do 4 to 3, 3 to 2, 2 to 1. I could do 4 to 3 and then 3 to 1. 4 to 2, 2 to 1. And if this is hard to see, remember I posted this PowerPoint so you can look at it in a bigger screen. And then I simply count how many different paths that I drew. But remember, we don't count doubles. So the n equals 4 to n equals 3, that happens twice. So I only count it once. And n equals 2 to n equals 1 happens twice. So I only count it once. So I have 1, 2, 3, 4, 5, 6 possible photon emissions for an electron in the n equals 4 state to return back to the ground state. So I hope this helped. We will be having a more formal assessment on this stuff soon. So make sure that you got this stuff down, that you're comfortable with it. Let me know if you have any questions. Have a great day.